Howdy, folks. You got Jim Meacham here, one of the principals at Altura. And today I want to take you through something like a demo of our approach to master systems integration. And I say something like a demo because master systems integration is really not just a product, really isn't a product, it's a process. It's a process that starts in design and goes all the way through the delivery of a project and then on into the life cycle of a building as additional systems need to get integrated. So it's all about master systems integration today. One of the services we do here at Altura, in addition to things like commissioning and data analytics and really everything around making buildings work and decarbonizing buildings as well using a programmatic approach. So some of the things we will discuss, defining what a master systems integrator is and why you should care, some kind of how you think about delivering master systems integration, how do you put that into your projects, your workflows, some kind of real world examples we'll take a look at, of course, and talk about what are some of the kind of key things to look for, the attributes, as you think about that for your potential projects. I think we need to start with what is systems integration, and in particular, where does this, the master part of this come from? And I'll just have to say right out of the gate here, and many of you may have heard this before, I don't love the master in master systems integration. It is kind of a term of art in our industry. It actually comes from the industrial controls world and has migrated over into the building automation and kind of commercial real estate world as well. And what we're talking about with master systems integration, or MSI, is really taking a look at a lot of these traditionally siloed systems, things like building automation, lighting controls, security systems, emergency power, medical systems, demand control and indoor air quality systems, fire life safety, and integrating those in a kind of new way to accomplish new use cases. In the past, when we thought about that type of systems integration, it was really done through the building automation kind of HVAC controls, Division 23 controls contractor. And so we're asking them to go do things with all these other systems which have specialty expertise, create new opportunities for value add for clients in terms of new use cases, but also have really different footprints often in terms of how we do that integration and why we would do those systems integrations, especially when we start to think about also being able to integrate beyond just facilities operations into more specialty systems like clinical operation systems, like a real-time location system, and how we might want to use that as a part of our practice as well. So we're talking about integrating now a much broader variety of systems for various reasons. And it really comes down to, why would you want to integrate these systems? We very much here at Altura take a use case driven approach. You don't just need to integrate everything for integration's sake. There are people in the industry advocating for just get all the data and then we'll figure out what to do with it. That can be quite expensive, especially when we don't yet know how to put that into workflow. So our approach is more about get the data ready to integrate, get these systems ready to integrate, and then integrate those things that make sense, that have a use case for adding value into your organization. So it's really about thinking through, how can we drive value from the integration of systems? A very simple example is a patient engagement system that you might find in a patient's room in a hospital, where we have a head wall display or some other type of iPad type display that the patient can interact with, touchscreen, where we want to integrate multiple modes of communication and control. The simple things like HVAC, I want to be able to make my room warmer and cooler. I want to be able to raise and lower the blinds. I want to be able to change the lighting scene and turn the lights on and off. But also that's integrated in the same platform where you're seeing who your doctor is, when your next medications are being delivered, and so on. So that's the type of integration that we're seeing evolve, more opportunity for that type of integration in the industry. And again, really be careful about the hammer looking for a nail here. It's how do we make sure we're driving things that make sense? Another very simple example that's been done for many years now in the industry from a systems integration perspective is doing an integration of a lighting control system and an HVAC control system, and using that lighting data to inform how we're operating that HVAC system when we start, when we go into a standby mode, how much ventilation we're providing, etc. So lots of different ways to think about systems integration. A master systems integrator brings a new perspective as well in terms of thinking about things at an enterprise level. Often we do projects and it's very much project-based thinking. How do I get these systems for this project to work? But a lot of our clients, especially healthcare, university, large enterprise customers, they want to think about things, and they're managing things at an enterprise level. So there's consistency standards, and particularly for cybersecurity reasons. So now we need to go beyond that project-based thinking. We really need to think, how does this project that I'm working on fit into the broader enterprise standard? And so therefore we got to start with what are those standards that are going to receive that project. So shifting gears a little bit, some of the reasons why we are pushing for master systems integration in the industry, or why we're seeing that gain more steam recently. One is the plethora of new technologies. We're seeing lots and lots of new IoT devices. Everything's connected. And so how do we manage that to an outcome that's actually useful? There's also a major cybersecurity component here. Traditionally, a lot of these systems were stranded, not connected to a converged IP network, and that meant opportunity for cybersecurity issues. And I'll say, in the past, the folks that we've known that have ended up with a ransomware, ended up in the news, it's often some stranded system that has a backdoor because it's not managed by the IT department. So getting over that hump, really getting it under the purview of your IT department, letting them manage the cyber with all the latest, greatest tools that they have, and getting that out of facility operations. So cybersecurity is a big driver. What's another driver? Energy efficiency. We see a lot of movement in reducing greenhouse gas emissions, reducing costs associated with energy use. And systems integration can be a great tool for that. We can standardize energy efficiency practices, optimization. We can participate in demand response and demand flexibility programs much easier when we think about this as an enterprise solution, again, as opposed to a vendor-driven project solution. In healthcare, you have things like patient outcomes. In offices, you have things like occupant comfort and occupant engagement. So those are key drivers as well. You know, really like who's using the building and how can we make their experience better. I mentioned enterprise and scalability. Scalability is huge, and that really starts with good standards and then builds out that enterprise approach using systems integration as opposed to, again, project by project. Vendor management, increased transparency of what's happening in your facilities at all levels, from operations, energy use, occupant comfort and engagement perspective, control from a centralized enterprise environment. These are all reasons that folks are really starting to lean more and more into a master systems integration approach as opposed to traditional, Division 23 driven automation and some of those other kind of more traditional approaches to delivering mechanical, electrical, and plumbing systems. Diving a little deeper here, what does this actually look like? And we can show a few images of what you can conceive of this master systems integration approach. And a lot of it is how do we make sure we're thinking of this as kind of a systems of systems approach that can easily be connected? And one of the things we want to make sure is that we're not losing the value of any of our data and those data connections behind any kind of superfluous vendor managed hardware or other software cloud where we don't need to. Sometimes we need to integrate with those systems. That's totally doable. And then it's just a matter of how do we do that. But in general, when we approach these types of solutions at Altura, we're really looking at how do we make sure we can make these data available across all of these different types of facility operations, clinical, other systems in a way that our clients own. And that comes down to network architecture. It's a big piece of what we're delivering. Network architecture is really critical to the foundation of success with respect to master systems integration. And when we think about network architecture, it's designing this architecture such that it's flexible and open and can add new technologies over time. Sometimes we don't know yet what we're going to do with these data. We don't know yet what that new use case is. We want to be able to get those data. And so it's about getting the right architecture in place so that there's no barriers to getting those data in the future. We really try to cut out the middleware and make this as direct as possible. You can see an example here where we're looking at those IP devices at the field level, really going straight up into the hosted cloud. That cloud could be an internal data center, it could be an external cloud, but really it's about bringing those devices and those systems as direct onto the network as possible, and then putting the management practices in place to make that doable. You have to think about things like large-scale BACnet networks, BACnet being the standard for a lot of the facility operation control systems in terms of protocol, communications protocol. But how are we going to manage that at scale? And also manage other types of protocols that we need to leverage to bring these data in and prepare for a future where there's new protocols like BACnet SC, MQTT, and those things. Before we dive deeper into how you approach master systems integration, how you can think about getting this into your projects, into your standards, it's useful to look at an example of how this is implemented. So we have a large healthcare client, had a traditional approach to building automation and their systems integration, which included, mostly vendor-driven field level controls, each facility or campus ending up with kind of a vendor. And so isolated to who could work on those systems and support them, and really no centralized visibility. A lot of isolated servers, cybersecurity risk, a lot of unmanaged risk in terms of the IP infrastructure. So we were able to work with them, come up with a new set of standards that defined how all these devices would come onto their network, onto a converged network, even in a HIPAA compliant environment, and then be able to tie up to a centralized systems integration architecture. In this case, we're using Niagara, Tritium Niagara as the integration environment, and we're integrating things like the building automation, lighting, metering, UPS, medical gas systems, and fire life safety. So we have central visibility now across the entire organization for all of these facilities that are spread across the U.S. That gives us the ability to manage the cybersecurity risk. We eliminate a ton of hardware, a ton of license management from bespoke softwares that have to be managed and upgraded and patched. It really cuts out a lot of the IT costs and hardens that infrastructure substantially. So that's an example of what this can look like, and really what systems get integrated are defined by your use cases. So how do you get started with master systems integration? And really, our experience shows that it starts with having a champion. Someone in your organization needs to own this initiative. It's going to be highly cross-functional. As I mentioned, we're talking about integrating all kinds of new systems now, IT, building automation, clinical systems, sometimes financial systems, energy management systems, all the O&M functions really need to have a champion who's able to cut across all of those groups, gather those stakeholder feedback, engage those stakeholders to build something for the enterprise that's truly valuable. So an internal champion is really a key first step in being able to advance your systems integration, enterprise systems integration initiatives. And as I've mentioned thus far throughout the presentation, standards. All of these enterprise systems are built on standards. That gives us the flexibility to adapt to different markets and different technologies if we have great standards. First and foremost, it's that network architecture standard. How do you expect devices to come onto your network? And that will help pull out some of the devices you don't want on their network that might have connection topologies that are not secure from a cyber perspective, or add additional cost and license management. So having a network architecture standard is the baseline. IT specifications go right along with that. What type of traffic is allowed to move where? How are we subnetting and VLANing and managing traffic across the enterprise? Those are key elements. How are we, what's our backnet numbering scheme? What's our IP addressing scheme? You got to have design standards as well. What are the expectations, again, for what systems are integrated and not? How much standardization can we drive in our optimization strategies and all these different use cases? If we standardize those, we can just push those out to design teams. We don't have to reinvent the wheel each time, and we get something that's much more accessible and maintainable over time. Another key set of standards is around all the data. How are we naming points? Point naming leads to point tagging. That's the ontology that really allows machines to do what they need to do with the data. So having standards for tagging, point naming, all of those things are really critical to success in building a standardized infrastructure. Graphical standards, so we're not reinventing the wheel, so we have consistency as people are integrating with different systems. What are those graphic standards and how are they maintained? Even contractual standards, what do we expect are the standard scopes of work at these different levels, so we have the right players doing the right things. Some other standards that you really should invest in. Most folks have some type of mechanical, electrical, plumbing systems and equipment and design and specifications. That's foundational. Obviously, you're building automation. The Division 23 or Division 25 standards are key. And alarming, scheduling, I mentioned sequence of operations, and now data analytics too. What are those standards around data analytics that you want to have? What fault detection rules should be implemented? What type of KPIs should be implemented on the different projects so that's replicable across your enterprise? Speaking about standards, Project Haystack, many of you know, is kind of the standard or one of the major standards in addition to BRIC and now the latest work from ASHRAE 223 around how are we tagging, using tagging at the point and equipment level to define what all these data are, what all these equipment are in our systems, and what are those references that define the relationships between the systems too. So I encourage you to lean heavy into Haystack-based tagging infrastructures. That's really going to set up for the future. There's a lot of evolution. There's a lot of competing standards. So it's really helpful to have someone help you navigate that part of the challenge. Finally, one of the things we've learned from doing this master systems integration work over the last 5+ years is if you've got great standards, you've got good procurement, you've got everything in place to deliver, you've got good designs, you still need to have oversight and validation of the delivery side of this. And this kind of gets into an administrative role that goes beyond even the individual project systems integration work. One of the terms we've been using lately with our clients is master systems administration. For any enterprise solution, there's an enterprise administrator for that, whether it's a financial solution or what have you. So the same is true here, where we're integrating all of these different facility, clinical, other operational systems. You've got to have an administrator, someone who's looking across the entire infrastructure and saying, is this working well? Are there any issues at any individual site or in the overall architecture? Are we running out of resources in our machines, the virtual machines that are running this? Are we having communications problems? Are our vendors doing what they should be doing and are really overseeing all of that naming and tagging and other work? So having someone either internally or externally who's really administering that solution is key. This is often a role we're playing with folks, building on the standards and design and QA/QC work is then administering the enterprise infrastructure to keep it healthy, make sure we're not having any server failures or other types of things. So as I mentioned, that oversight and kind of enterprise systems administration is the key component of the ongoing management as well as the project delivery. And an example I always like to point to is something we've done with UC Irvine in California. We've been able to help them work on transitioning from a historically proprietary system to an open Niagara-based integration platform. And we have multiple systems integrators working across the campus now. So we have a good competitive landscape. And here's an example where we had 3 different vendors working across 3 different projects. And you can see the outcome looks exactly the same. And this is just a visual representation of what this can look like. We want that consistency for our operators, for our data analytics, for our back-end use of any of these data. We need that consistency. So that's what it's about. Standards can work, and really investing in that from the beginning all the way through verification, validation, and implementation. So what does this often look like in practice on your projects? One of the ways that we think about this is, a building, again, is a system of systems. There's electrical systems, switch gear monitoring systems, and lighting control systems, and metering systems. They're all different systems provided by different vendors. Building automation is an example of that for the HVAC system. Other types of bespoke, fire life safety and all those kinds of systems. So we want to have the best of each of those systems. We want to have the best vendor, and we want to have an open and resilient architecture, as we talked about. So we think about separating kind of the head-end enterprise architectural piece from the field application of these systems. So the simple example of the building automation system, you're going to have a local controls contractor who can install hardware, wiring, sensors, all the HVAC components, for example. They don't necessarily have to be the one then who's doing the master systems integration. So we can now think separately, like who's the best firm and partner to do the systems integration work, and how does that fold into your overall approach? So that gives us a lot more flexibility to work with the best hardware in a competitive landscape and get that consistency at the enterprise level. So often Altura is doing the actual integration work up into the Niagara platform as an example. We're managing that software integration component. We're not doing any of the hardware pieces. We're not providing any of those systems that are all in the building, but we're helping navigate what are the best systems, and then how do we make sure those can all be integrated how we want them to be integrated up to that head end. In that head end now, that virtualized, centralized enterprise system, we can do some new things. Obviously all the standardization we talked about, but also that new deployment of optimization. So we can have optimization live up in that layer as opposed to distributed across all these different projects where you might get a different interpretation of how to optimize from a Distech provider to a Siemens provider to a Johnson Controls provider, et cetera. So we standardize that. We make it a lot simpler now for those field level systems to be implemented because we're pulling a lot of that complexity of things like ASHRAE Guideline 36 out of their scope, and we're managing that at the enterprise level. So something like a supplier temperature reset, an optimized start, an unoccupied standby algorithm that's based on a lighting occupancy sensor. All of those types of things can now happen up at that enterprise level. And again, simplifying and making the local field level much more resilient. So when we think about master systems integration, what are some of the key attributes of success and the folks that we see succeeding in that space and for ourselves? And we think there is a strong correlation between separating the hardware and the provision of any individual system in the field from that enterprise software environment. It's not 100% the case, but I say 99% of the time you can optimize resources and who's best suited to do those different types of work by separating those two layers. So that allows you to, again, get the best energy metering system, the best building automation system, the best lighting control and other types of systems without tying that into who's really the most capable of managing an enterprise system and managing these types of standards and deploying optimization at scale. Those can often be two different entities. So again, a role that Altura is often playing is as that software side, that master systems integrator side. Throughout this discussion today, we've been talking about expertise that's really way beyond building automation. We think that that's a key attribute of master systems integration. Exposure to and understanding of all the different types of communications protocols, APIs, things that go beyond building automation. When we get into systems integration, we have to be able to do new types of integration work. So really it's going beyond thinking about this as just a controls contractor. It's something different, right? And I've mentioned it a few times, but I can't reiterate this enough. It's enterprise thinking versus project-based thinking. You can have all the best standards and specs in the world, but if you just deploy that on a project and don't really enforce the enterprise element of it, the folks on that project team aren't going to be thinking about what this means for 5 years down the road for your enterprise when you have 20 or 50 or 60 different buildings or sites online. So you really have to make sure enterprise thinking is at play here. Okay, so where does master systems integration make sense? And generally, from our experience in doing this over the last 5 years, a few different places. Primarily, we're looking at campuses, multi-building, multi-site campuses and enterprise applications, healthcare, university, large enterprise type applications where you can really think about these things as enterprise solutions. We're also seeing some advantage in some really big, complex healthcare projects, even that aren't yet ready to move to that enterprise scale, just to help add some horsepower to the delivery team and again, focus kind of expertise across large scale networking solutions and integration that are required even in 500,000 square foot healthcare project, for example. An MSI approach can be really advantageous than a traditional vendor-driven approach, I'll say. So we've been talking a lot about what master system integration is, how do we get there, what are some of the attributes of successful MSIs out there in the field. And now I want to talk about, coming back around to the why. It's what are the outcomes that we can expect from this approach? And I'd say first and foremost, improved cybersecurity. Having an expert who's got IT, cyber expertise on the team, looking at all these different systems alongside your IT groups is really a requirement these days. There's so many new systems, varying levels of sophistication in IT and the way that they connect and want to use cloud systems or not. So a big outcome is making sure you're getting truly secure systems in a converged network environment. It really should also include reduced ongoing IT costs. If we can get rid of a lot of the traditional licensing and maintenance costs of some of this excess hardware, and we centralize that into a virtualized environment, we can really drive a lot of cost savings from our infrastructure management. Reduced energy costs. This is, through these standardized optimization, really having someone looking at whether that's working or not. Using data analytics and fault detection now is much simpler, and having that a part of your MSI approach, make sure you have the visibility to really see the performance of all these buildings in a quantitative sense. Not, it's building on commissioning. It's got to go beyond commissioning. It's show me the data that say that I'm meeting energy efficiency goals, that my thermal comfort is good, that my ventilation is meeting the design intent. Obviously, occupant comfort, safety, and health is key. Proper ventilation, proper temperature and humidity control. We have now more access to those data, so we have the transparency of performance. So really, having an MSI approach gives you the ownership of that data architecture and all those data that you can do all different types of use cases, right? We have clients who are doing automated utility recharge, obviously data analytics, fault detection, all the dashboarding. Decarbonization planning has been really a boon for our clients who have had data analytics platforms in place for multiple years. Leveraging this type of approach means that they have all this data that they can just hand over to those decarbonization planning teams. So a lot of value can be driven by taking this MSI approach that really focuses on data ownership. So we have a bunch of examples of what this can look like, from measurement and verification, energy performance over time, and key performance indicator tracking. So when done right, when paired well with standards and processes, you can really drive a lot of enterprise value. We've learned a lot of lessons in building this out here at Altura over the last few years. How to manage your enterprise networks and the administration of those over time, how to set that up for success, managing all the little details around BACnet and some of these other protocols to make sure we have good responsive systems and data flows, managing multiple vendors out in the field and making sure we can get consistency and quality across the enterprise. All of these things we'd love to talk with you more about. If you're interested in taking on an enterprise approach to systems integration, feel free to reach out to us. We'd love to share with you our lessons learned and how we might be able to work together. Thank you. Have a good rest of your day.